side is opposited? BC, which has a measure of 3. The sine is the opposite leg over the hypotenuse. Okay, well, it doesn't matter where your angle is because your hypotenuse is always your hypotenuse. And our hypotenuse in this case is 5. Well, is the cosine of A also going to be 3 over 5? No. The cosine of A is the adjacent leg, the leg that is touching angle A. Well, there's only one leg touching it, and it's this. It's 4. This is not a leg. This is the hypotenuse. So the adjacent leg, 4, over the hypotenuse, 5. And the tangent of A is equal to what? 3 over 4. The opposite leg over the adjacent leg. Okay? Now, if I wanted you to also find the cosecant of angle A, the secant of angle A, and the cotangent of angle A, once you know the sine, cosine, and tangent, all you have to do is invert the fraction. If the sine is 3/5, then the cosecant is 5/3. If the cosine is 4/5, then the secant is 5/4. And the cotangent is 4/3. The first part of your homework tonight is going to be to find the 6 trig functions of a right triangle. And this is what you're going to be doing. The thinking part is going to come in identifying these first things. But for the next 3 functions, all you've got to do is simply invert this fraction. Plus, you got to know which ones are inverse of each other. Okay? Now, how are trig functions useful? Remember, we said the Pythagorean theorem helps us to find one of the lengths of one of the sides, but we have to know what? We have to know 2 of the other sides. In the sine, cosine, and tangent functions, do we have to know 2 sides? No, we don't. Because if we knew an angle measure and one side, we could find another. Okay? So these functions are useful when we don't know 2 sides of the triangle, but we do know at least one angle measure. And we're going to choose which function we are going to use based on what we know. For instance, if I give you this problem, I tell you that angle C has a measure of 48 degrees, and your hypotenuse is 12 units long, and that's all I tell you. And I ask you to find the length of AB, and we'll designate that as X. Well, we can't use the Pythagorean theorem because I don't know what to square here to set up and make my equation work. But I can use my trig functions because I know one angle and one side. Now let's figure out which one to use. In reference to this angle, I have information pertaining to the hypotenuse, and I'm looking for what leg in reference to this angle? The opposite leg. So think about your trig functions. Which trig function deals with opposite and hypotenuse? Sine. So I can use my sine function because the sine of my angle, which now I know is 48 degrees, is equal to the opposite leg, which is designated X, divided by the hypotenuse. Does everybody see how that works? Suppose that was not the leg I was looking for. Suppose this was the leg I was looking for. Is sine function going to find it for me this time? No. Sine function is going to find the length of AB. What function will find for me the length of BC? The cosine function. Because the cosine of my angle is equal to the leg adjacent to that angle divided by the hypotenuse. So that's why these functions are helpful, because it really doesn't matter which two things we know, we can figure something out. Now let's look at one more possibility. Suppose these were the three given things that I am either knowing or looking for. I cannot use Pythagorean theorem. I don't know at least two sides. But I can use a function. Tell me, in relation to the 48-degree angle, which function can I use to find the missing piece? No. Sine and cosine both deal with hypotenuse. If you don't know the hypotenuse and you're not looking for the hypotenuse, then you're not using sine or cosine. It's tangent. The tangent of 48 degrees is equal to the opposite leg, which is x, over the adjacent leg, which is 10. Now, if we actually wanted to find the value of x, this is an equation. How do I manipulate this equation to get x by itself right here? I multiply both sides by 10. And in multiplying both sides by 10, I've got 10 times the tangent of 48 is equal to x. Now the tangent of 48 is an actual decimal number. Everybody get out your scientific calculator. Our calculators are only as smart as what we tell them to do. So we have to know how to correctly operate and use them. If you look somewhere at the top, you should have sine, cosine, and tangent buttons. Right above those buttons, you should have sine to the -1, cosine to the -1, and tangent to the -1. Okay? That's what I'm going to tell you in a second. All right. How do I know whether to use the regular button or whether to use the second function key? When you know the angle measure right here, you simply hit sine, cosine, or tangent. When you know the angle measure. So right now I want us all to find out what is the tangent of 48. You are going to hit, some of you may hit 48 first and then tan. Others you may hit tan and then 48. You should get, everybody check your calculator, because if you're not in the degree mode, it's not going to give you the right answer. You should get 1.1106 yada yada. Is that what you got? Okay. Now, when do I use the second function key? If I'm looking for the angle measure. Okay, so right now I want you to clear your calculator.
What do you do with it?
Once again, I'm going to do it in a second. Once again, I want you to find the tangent of 48, punch it in. Okay? Oh, I don't know how to do that now. Just remember 1.1106. Now hit second tan, 1.1106, and tell me what you get. Rounded.